Hello everyone, we are AIOps intern at Pegatron, and today we are excited to introduce our project which focuses on using AI to improve IT operations in the cloud. Our presentation today will cover these 7 sections. We will start from our motivations, like the key issues and problems that we are addressing. Next, we will present the solutions that we offer to overcome these problems. Toward the end, we will share our progress, future work, and how our team collaborated while working on this project. So we will go to the first part of this presentation, the motivation behind our project. Our project is a small piece of a big puzzle. As we all know, factory production line is a very complex system. To give you an idea, a network attack in factory production line can cause information leakage or maybe more serious problems. And aside from security issue, other routine tests may also lead to large amount of workload. So in the long term, to make them more efficient, we might need to build models that can predict upcoming years' production capacity, or maybe develop a system that can detect irregularities or problems in real time. While these solutions improve operations, they will also increase workload on the server and make things harder for the operational engineers. So this is where our line bot comes in. It helps to streamline these processes by allowing users to easily query the server conditions and stay updated of the system performance. Our project uses an AI assistant to reduce the workload for operational engineers. This assistant will translate users' requests into operational commands, so it can handle routine tasks like checking storage space or maybe updating software. And this way, engineers can focus on more important tasks or emergency situations. In our design, the AI assistant has 2 main responsibilities. First is to always be ready to answer users' queries, while also monitoring the servers and sending alerts to users when needed. With long-term monitoring, we can implement production capacity predictions and irregularities detection using the collected data. Second, the AI assistant should be able to perform routine operational tasks and contact engineers in critical situations. So, what solutions do we offer with our project? In brief, we want an AI assistant which can help us deal with server operations. It should be able to be controlled remotely and send critical alert if needed. For simplicity, we also use an AI-guided interface that users can be familiar with in a short time. This is the design architecture of our linebot. We start with an overview of data flow between server and endpoint users. The requests are connected to the cloud through social apps such as Line or Teams, and these messaging apps will connect to the AI assistant and server. So in the beginning, we will issue a chat ID in each conversation. Our AI assistant can clarify different inquiry targets by using these IDs, and it will also avoid messing up with various servers or applications. In the second part, we send response to the chat by combining Pega AI and large language models, or LLM. In each conversation, Pega AI assistant will connect with LLM using chat ID that was issued in the beginning. And then LLM will analyze user requests and access the corresponding metrics from a monitoring software called Prometheus. Then the dashed line section over here is our future work, because given security concerns, it is important to build a verification mechanism because we don't want just anyone can access the server data. And this mechanism will also differentiate users or groups based on their authority and permissions. Therefore, the verification process will consist of 2 parts. The first part is authorization, which will identify users, and the second part is authentication, which will determine the permissions for users. In conclusion, we can access our cloud server using various software. We start with tools for users such as Line or Teams, and then the message will go to the LLM through Pega AI Assistant, where Pega AI Assistant will turn user requests into comments that server can understand. And then finally, we can go to Prometheus to access the status of the server. Next, we will demonstrate how to use our linebot. In the beginning, user will need to send Pega start to start the bot. When this keyword is sent to the bot, a chat ID will be issued and forwarded to the LLM. So LLM will know which conversation is connected to this chat ID. and each conversation has a unique chat ID, so user can use the chatbot independently. Once the chat ID is created, user can inquire the status of the servers and do any queries. After the first query, our bot will provide suggestions for further operations. For example, here our bot will specify some comments to the users, and users will also be asked to review and confirm the operations before they are implemented. Then when users finish their operations, they can end the conversation by sending the keyword Pegatron. This way, the chat ID will then be clear and user will need to start a new conversation before sending another message. To enhance convenience, we also added a feature that can convert text-based data into visual representations like pie charts or graph. So we will now take a look at our progress on the project. For the basic requirement, we have successfully built a mechanism to access the status of the server. It also allows multiple users, multiple queries, and multiple responses. And to make it easier to use, we also added a rich menu or button to our line bot. And lastly, we built a function that can convert text matrix data into pie chart, but we haven't integrated this function into our line bot yet. For future work, we still have some issues that needs to be solved and modified. First, we need to create a verification system to identify different users, and this system will also allow users to perform comments based on their authority and permissions. Next, we also want to connect to other Pega service to enhance and add more features to our bot. And additionally, we are considering to add visual server metrics and also find ways to reduce the waiting times. So for the teamwork during the whole project, we use Scrum method to manage our work. Before every sprint, we will do a sprint planning where we will break down our goals into subtasks and assign them to team members before starting the project. And there will also be performance and feedback review at the end of a sprint. In these 4 months, in total we did 3 sprints from mid-July to early September, with 1 sprint lasting around 12 days period. And these are the details of the subtasks from each sprint. Last part, our collaboration method. So we use the Scrum methodology to manage our project, along with tools like Redmine to track everyone's progress. And we also had offline discussions and online discussions with Microsoft Teams or Outlook. And for code management, we use GitLab to keep everything synchronized and ensure a smooth collaborations across the team. So this is the end of our project presentation. Thank you for listening.